So hi, um, this is a new format where I played with a little bit filters for the ABS. So now you spot the difference. I don't have a background now. It's like transparent. You can focus on my image or like video, or you just focus on what I do on the screen. So this is a new format. During this format, I will just try to improve. Like it's more like a retro, where I try to improve my previous solutions or like come up with a better approach or like fix the issues I didn't manage to fix during like pass or fail standard format. So it might be more extended, like not like 20, 30, 40, or like 1 hour, maybe like couple hours videos. We'll see. I'll see how it goes. But usually like it's just a follow-up to the tasks I either have not solved or not solved efficiently, or like have maybe ideas for improvement. So this one gonna be for the recent video for the task 904 fruit into baskets. I managed to solve that using hash map, and it was kind of efficient, but not that much because I was using hash map, where in reality I can just use a couple of variables, so on and so forth. Um, so I'll just copy this approach and I'll try to elaborate more about like what I have in mind, and yeah. So I'll have this task. Just a few like a short reminder what the task is about. So we have fruits, and basically we are gathering the fruits into our two baskets, and we have like fruits array that contain the type of the fruits we see in the line. So like here we have like two types, fruit number type 1, then type 2, then type 1. And the rules for gathering the fruits, we have just two baskets. In every basket can have like maximum one type of fruit. And and when we start gathering, we can like have windows of gathering. We cannot have a breaks. If we start gathering at 1 and end at 3, we cannot break at 2. Like say just gather 1 and 1 here. We need to make it as a sequence, so sequential fruit picking. And having like two baskets, we need to figure out what the maximum number of fruits we can gather, given these rules. Two baskets only hold a single type. One basket can only hold a single type of fruit. The baskets are basically without bottom, so we can gather how like whatever number of fruits we have of the same type in a single basket. So we must pick exactly one fruit from every tree. We cannot skip trees. If we start picking, we should continue picking. As soon as we fill up the basket and we cannot see the like here, we cannot find a place for fruit type 2, we should stop. And basically the question is what's the maximum number of fruits we can gather. So I had this approach of I just walking. I have a map. For the key for the map gonna be the fruit type, and the value for the map gonna be frequency. And I go one by one for the fruits, and I check if the map size is equal to, and the current fruit is absent from the map. Then it means that I need to evict one fruit, and so I evict basically the tail of this sliding window, where the sliding window begins, and I evict one. By saying evict 1, I say that I decrease the frequency. If the frequency becomes 1 and I need to decrease it further, I just remove it from the map. And yeah, do some cleaning, move the left pointer to the right, decrease the current fruits number, and then as soon as I figure out that there is less than 2 keys in the map, I can move further and allocate a basket to a fruit. Like one second basket, I can put fruits in a second basket. So my idea was to have this two baskets. And let's have this case where I failed actually. Um, so this one is a sequence of fruits. Have this sequence of fruits, and then we'll have, let's say, so we have like we have basket one, and then we'll have like format type and frequency, and then we have basket 2, and we have a sequence of last fruit, sequence last, let's say we have last fruit sequence, and then we'll have kind of number of fruits. So current fruits, car F. So here initially we have pointer at 3, so we put initially like in basket 1 gonna be type, let's say, gonna be type 0, frequency 0. Again, I need to think about maybe type 0 is not that good in terms of like, it can, like if the type gonna be 0 at the start, it's gonna break it, but let's say we have like, so fruits can have, let's say, fruit -1, so initially fruit -1, value 0, and we start with the basket 2. So we put fruit type 3 into basket 2, so basket 2 becomes 3, 1. We increment the last fruit sequence, and we increment current fruit sequence. We go further, we have like 3, so again -1, 0, and here 3, 2. We increment the last sequence, we increment the current sequence, and we have like 3 again, so -1, 0, and here 3, 3. We increment last fruit sequence equals 3, and then current fruit equal current fruit number equals 3, and then we have 1. So like 1 is different from the type 1 is different from the basket 2 type. So 3 is not equal 1. So we basically what we do, we should and basically 1 is not equal to basket 1 type. Here is like -1. So what we do, actually we can end with 0 even, not to have this. So what we'll do is we should basically drop everything we have in basket 1, and we should carry what we have in basket 2 into basket 1. So we have 3 fruit type 3 items of it. We moved it into basket 1. So basket 2 will have now fruit type 1 value 1. Last fruit sequence, we what should we do? Because we dropped current, we dropped like 0, basically was empty. We subtract, so we do that 3 from the current fruit. We subtract whatever we dropped, my volume, and because we added 1 fruit type 1 we add 1, and last fruit sequence we restart the fruit sequence, so it starts with 1. So here is equals 4 current fruits volume, and we go again to 2. So we check if the 2, so here is like fruit 2, fruit 1. So we check if we have fruit 2 in the basket 2. No, we don't. We check if we have fruit 2 in the basket 1. No, we don't. So it means that we need to drop whatever we had in basket 1. So we and put the whatever we had in basket 2 into basket 1. So we do 1, 1 here, and we have another fruit 2. We put the fruit type 2 into basket 2, and then last fruit sequence, again we reset the last fruit sequence, and then current fruit we dropped, so it was 4, we dropped 3 fruits from basket 1, we added 1 because as a basket, like as a fruit type 2, so the end gonna be 4 minus 3 plus 1 gonna be 2. So again, next fruit is on to 1. Okay. So the next fruit gonna be 1. We check if 1 is equal to fruit type in basket 2. No. If 1 is equal to fruit type in basket 1. Yes. In this case, we don't drop the basket 1, we just flip it between each other. In this case, we'll have fruit type 2 will go to basket 1, and fruit type 1 go in basket 1, plus we will record additional 1 fruit, so it's going to be 1, 2. Last fruit sequence. We need to reset last fruit sequence. It starts again with 1. And in this case, we just added volume of the number of fruits we currently hold, like 2 plus 1 equals 3. So next one, we move our pointer fruit equals current fruit is equal 1. We do this, we check. So 1 equals 3, last fruit sequence segment 2, we'll add 3 plus 1, gonna be 4. Then we move to fruit 2. Again, we flip, because like fruit type 2 in the basket 1, we flip them. So 1, 3, and here like 2, 2. Last fruit sequence. Last fruit sequence gonna again we're gonna reset it, and we're gonna increase increment 4 plus 1 gonna be 5. So next I'm gonna move to the next pointer to the 3. So the fruit equals 3. I check if the 3 contained in a second basket. No. If it contains in the third basket. No. In this case, we need to drop whatever we have in the first basket. So we'll have fruit sequence with that. We'll have number of fruits. We need to number of fruits equals. So we dropped 3 fruits, so we need to just subtract 5 minus 3. And we move that we have in second basket into the first basket, so we do 2, 2, and then 3, 1. And here is 2. Then we go again, fruit 3, we do this, keep there, 3, 2, 2, 5, plus 1, so we're gonna be here 3, and then I'll have sequence 2, and then 3 plus 1 equals 4, and then I'll have a fruit type 4. In this case, we have fruit type 4. we'll check if we have it in either first or second basket now. So we drop whatever we have in this first basket. We do this reset sequence. We do the change the number of fruits 4 minus 2. We do carry the fruits in the second basket into the first basket. We add to the second basket fruit, and we increment their current volume in the basket. So it's going to be 4 minus 2 plus 1, it's going to be 3. Okay, so this is the algorithm, and we in the end on every step we check if a new volume is greater than the maximum, and we select whatever we have for the maximum current volume of fruits in the basket, and in this case it's going to be 5. And here also check, I should check this, and the 5 maybe max. Okay, so let's start programming that. So I have this implementation. Let's copy this one. Let's say we have, okay. So we need to go for int I equals 0 I plus and fruits length I plus plus, and then we'll have variables int basket 1 type equals 0, int basket 2 type equals 0, int basket 1 volume equals 0, int basket 2 volume equals 0, and then int car. So I'll do this current frequency, current volume, current fruits equals 1, let's say, and max fruits equals 1, and then current volume and current sequence equals 1. So I'll put the fruits of type let's have, like, I hope we have length greater than 1. Okay, so I will do this volume equals 1, and then we start from the first one and we check if fruits I equals basket 2 type. If yes, I just gonna increase B2 volume, and then I'll increase current sequence, and then I'll increase current volume, and I'll say max frequency equals max f, and then current volume. Else, if fruits I is not equal, is equal B1 type in this case, and then else if it's not equal. If it's equal to B1 type, what I need to do? I need to swap baskets. So I need to do this int temp t type equals basket 1 type, int temp p volume equals basket volume, basket 1 volume, and then I need to record the basket1 type equals basket2 type, and then basket1 volume equals basket2 volume, and then basket2 type equals btemp type, and basket2 volume equals temp volume. And then I need to reset the sequence, current sequence equals 1, and then I need to basically increase current volume by 1, and then do this again, max update the current max roots. If we don't have this one, if there it's different, so we need to evict basically whatever we have in basket1, and we need to reset the sequence, yeah. So let's try. So we need to current max current volume minus equal current volume minus equal basket 2 volume, basket 1 volume, and then current basket 1 type equals basket 2 type, and then basket 1 volume equals basket 2 volume, and then basket 2 type equals fruit I, and then basket 2 volume equals 1, and then car sequence equals 1, and then current volume plus plus, and then max f equals this one. Okay, and then we need to return max f. So let's check if it's gonna work for our case. Static void test1. We have this case, where is it? Submissions. This one, the expected is 5. Int fruits. So call this one. Int bracket out equals 5. Main solution. New main solution. Total fruit. And then we'll pass fruits, and then it's gonna be int output equals this one, and then I have boolean passed equals output equals expected output, and then system out println test1, and then passed. I probably need to have the template for this one, because I'm basically tired of writing that one from scratch every time. So we have expected output. Just one. I don't wanna spend like time. Let's try to run it. Car V. Car fruit. 14. 30. Okay, so we don't even need this current, probably let's check it. I assume we don't need it. Um, Not really. So let's assume what they do here. So they have 10343. Let's check it out. Why we don't have it? So in this case, I go. Let's assume I go to this pointer 1, basket 1, 0, 0. I have basket 2. Okay, basket 2, 1, 1, current volume 1, car sequence, let's say current sequence, current volume 1. So we check if it's 0, or so we swap the basket, so like this 0 becomes 1, and 1 becomes 1 here. We reset the sequence becomes 1, current volume becomes 2. So we go to 3. We check if this is, we drop this one, and we move the basket 2 into basket 1. We add 3. Current sequence becomes 1, current volume, we dropped 1, so current volume 1 plus 1, so it should be 2. So next we see 4. 4 is not containing anywhere, so we do the same for 1. We reset the sequence, we do minus 1 plus 1, 2. So we do again 3. 3 is contains here, so we reset the, we swap it, we swap them, we do 3, 2, 4, 1, we reset the sequence 1, we add the volume 3. Should be 3 here, but why we have 4? Guess I missed a few. So in case we have a basket, in case it's not equal case, it's here basket 1 t, temp t, we swap it. Okay, we need basket 2 volume probably here. Basket 2 volume plus plus. Yeah, something like that. Okay, let's figure out basket 2 volume. And still, okay, another one. we are moving. So we have here, what is this sequence? It should be 5, we have 6. So again, let's trace it. We have, initially we have basket 1, basket 2, current sequence and current volume. So we have basket have type here 0, volume 0, type 1, volume 1. We have current sequence 1, current volume 1. Next we have 0. We see, okay, we swap it 1, 1, 1, and have current sequence reset, current volume increase. Say we have 1. We swap again it. We have 1, 2, 0, 1. And then current sequence 1, and then volume 3, and then we have 4. 4 means we should drop here, drop this one. So like this is gonna be 1, 2, and then 4, 1, and then it's gonna be reset the sequence, and then current volume we dropped 1, so 3 minus 1 plus 1 gonna be again 3. So we go into 1, 1, we swap the baskets, so we have 1, 3, 4, 1. We reset the sequence, we add the volume. So 3 plus 1 gonna be 4. Next one, we have 4. We again swap them. We have 4, 2, 1, 3. We have reset the sequence and we increment the volume 5. Then we have okay, so I guess I got it. So we have like on this one, but actually here we broke the sequence here, but we still were accounting for this first one. Yeah. So whenever we actually drop the, like, we not swap, but drop the in this case, whenever we don't swap and not the same, we need basically to kind of drop the end of this tail. That's why I have this current sequence. So so we dropped here we have like 1, okay, 1, and then we have like 4 arrived, and we need to here because we are dropping zeros, we need to save just 1 into there. Instead of 1, 2, we need to save 1, 1. Yeah, 1, 1. It should be 1, and then it should be we should current volume should be reset by the number of, decreased by the number of basically we can current volume, we can save it by like calculating the this plus this. So whatever the current sequence here, we need to b fruits volume b2 b1 b2 volume, it's equal current sequence, and then current volume equals b1 b2 b1 volume plus b2 volume. Okay, let's test it. Test, let's say 6. And expected 5, we have 6. Expected 5, we have 6. Int roots equals this one. Expected output equals 5. Main solution. So let's copy this one. Tests, whatever we have here. Test 47. Let's check it. Okay. No. Okay, let's run it. We can even improve. We don't need the current volume. We need to do this B2, B1 volume plus B2 volume. Yeah, memory not that good, but again I'm just saving couple variables here and there. Runtime is more or less good. So memory, what's happened with memory? Counters here and there. Why? Let me check this one. This one is counter. And we have fruits, and this one is very long array. This array is kind of basically 10 to the power of 5. Yeah, 10 to the power of 5. Weird. Submissions. Memory, let's check it. Memory. Oh, the memory. Can we go with memory? I wonder why. Why is it so? I wonder if I gonna save that Mm, in array. Okay, let's check it out. We have this submissions. Where is it? Code. I need solution. This is my solution. So I need to just save everything into array. If you're gonna save everything into array, will it help us? Saving everything into array. So I'll do this. Int b, what's even, baskets. Baskets. So I'm gonna have int for, let's say 5 variables. Like, let's say new int 5 and 6. And then I'll say b, let's say b, just b. b0 gonna be b1 type. b1 gonna be b2 type. b3, b2 gonna be b1 volume, and b3 gonna be b2 volume. Let's change it as of now. So b0 b1 then b volume, then this one b2, b3. Okay, let's try to run it to see if it works. My idea was to save also the all interim variables into this array. Let's run. Compile error. Oh no. Let's check what's happening here. Run. Oh, sure. Okay. Memory not that good. Not at all. Why? I wonder why. Why the memory is that bad? Let's do that even further. Let's say b4 gonna be current sequence. and b5 gonna be max f. Okay, let's check it out. Very interesting. What gonna tell us? Memory still bad. Have we missed any GC clean here? No. I wonder why this. Maybe this check. Nope. 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 Default. That's very interesting. Why, if we have this is something weird happening with this algorithm. If we have this root length I equals 0, result equals 0, and counter equals what? Counter equals. So we have a counter for the fruits, and it's especially long, and the type is equal 0. So we go and we check the counter if the type, okay, type is very, okay, type is equal fruits, okay, counter fruits, if type is greater than 2. We have two, okay, we have two types. Interesting. This is interesting formula. So if we have more than two types, we just decrement the counter. This is just a maximum, I assume. Maybe the problem is this maximum. If we have more than two types, what we do? We need to okay, we have like the tail pointer. Yeah, we have a tail pointer. This is I, like the left pointer. This is I, and the yod pointer is basically right side. And we have this. If you have type 2, yeah, we have just maintaining this frequency and maintaining the length. Maybe max is not working that efficiently. still. Yeah, it's hard for me to understand why this solution has a better memory footprint. We have like just constant memory, and that one is like linear memory based on the size of the. Not linear, like constant, but like it's a huge. So it can be 10 to the power of 5 because the types, the values is less than fruit length, and that fruit length is 10 to the power of 5. So in theory, this one solution, this solution can generate basically a huge the frequency counter array. We allocated it once, and we do this. But this is like constant memory, like maximum 6 integers. If I do short, what will do if I do short? Do we have even short? Short. So short has 2 to the power of 4. Calculator. So 2 to the power of 4 equals 2 to the power of what? 2 to the power of 8 basically, yeah. Yeah, that's not much. It will not work. Why? B2 short. Empty. Okay, empty. I'm gonna be also short. Where is it? Short. Short. No. It's from int to short. So if you do plus, it does short conversion. It does int conversion. So if I do plus here, yeah. Yeah, that's interesting. Why this? The main question is why this is like so great in memory. Yeah, and not that good in runtime also. This one is kind of boring. Okay, I'm gonna wrap up. So basically, I built up the kind of approach that's improved for the memory and for the time complexity. So I managed to basically, you cannot see it here, but yeah, like memory is better here. Time complexity kind of So the time complexity beats like 94%. Memory is still not that good, but I don't understand why. So I have just a couple of interim variables here and there. I have baskets kind of approach. If I see the fruits that already of type in the basket in the second basket, I just increment the second basket volume. If it has in basket 1, the first basket, I just swap them. If it's not in basket 1, basket 2, I just move it to the just move it to the basket 2 fruit. I move to basket 1. I draw basket 1 fruits, and a new fruit of type I move it. I collect it in basket 2. And I also have this current sequence, and that's gonna be the last fruit type sequence, and we need to maintain it to basically to account for this breaking sequence. In this case, we were counting, so it was 1, then we put 0, then put again 1. But actually, when we start allocating 4, we need to basically drop not only a single 0 from here, from the bucket, but we need also to drop the left pointer, not left pointer, but whatever we have like on the left side. Because if you drop 0, it means it introduces a gap in our sequence and we need to account for this gap. Yeah, that's it. Hope you liked it.